Hello, welcome to the lecture series on automobile engineering. In this session, let us talk about vehicle steering. Those who are driving cars, steering is not new to you at all. I'm just going to discuss the various types of steering systems that are used in modern cars. I'm not going to talk anything about the design of these steering systems. So only I'll be descriptive in nature. I just describe the systems. The word, what exactly we mean by steering? The purpose of the steering is to change the direction of vehicle movement as desired by the driver. For that, we use a steering system. First, let us understand the steering principle. So we have Ackermann or center point steering principle. It's what we talk about. What exactly an Ackermann steering system is? You just consider the vehicle here. Now I am steering this vehicle to take a turn. Then you can see this is the inner wheel and this one is the outer wheel. Now, let me at the midpoint of this tire, let me draw a perpendicular. Okay, when you see from the side, let me draw a perpendicular. So draw the perpendicular to this. Similarly, for this wheel also, I draw a perpendicular at the midpoint. The rear wheels also I draw. All these wheels, all these lines will meet at one point. About this point, you see here, this is a circle. It traces, this wheel traces this circle. Again, this wheel traces this circle. This wheel traces this circle. So you get a number of concentric circles. Right? If I just again produce this backwards, they meet at a point. So it is designed in such a way, you can see this inner wheel makes a larger steering angle compared to this outer wheel. This turns more than this, so that this can cover lesser distance and this can cover more distance. This is what we call it as Ackermann steering principle. So here I have written the intention of Ackermann geometry or Ackermann steering principle or Ackermann geometry is to avoid the need for tires to slip sideways when following the path around a curve. The geometrical solution to this is for all wheels to have their axles arranged as radii of a circle with a common center point. As the rear wheels are fixed, this center point must be on a line extended from the rear axle, intersecting the axis of the front wheels on this line as well. Requires that the inside front wheel is turned when steering through a greater angle than the outside wheel. That's what exactly. This delta I must be larger than delta naught. Okay, this is Ackermann steering. How do we achieve this Ackermann steering principle? So let us look at the geometry that we should be designing. Now you look at this and just consider this is a steering rack. And these are, you call them as tie rods. Tie rod. Okay. So this is the steering arm. This is the tie rod. This is the tie rod. This is the steering arm. Of course, this is steering knuckle here. You have steering knuckle. Now, if I join these 2 points by a line, by an imaginary line, you see here this is a trapezium I'll get. So it's a trapezoidal geometry. And the steering arm, what I have, if I just produce, and for this steering arm also, if I just produce, the lines that are produced will meet at the center of the rear axle. Then it is, if we design the geometry in this way, then delta I will be greater than delta naught when you are taking a turn, and it meets the Ackermann's requirement. Okay, so something you see when we design the real steering mechanism, so we may accommodate this beyond this front axle, or it may be ahead of this. So that is what we mean by rear steering suspension, right? I'm just beyond this. So in this case also, when we produce this, as I said, it will meet at the center point. So even if you have it at the front, you should meet the same requirement. Okay. So now let us talk about what all those values. Can we express this delta naught, delta I in terms of known values? What are the known values? This is what you call it as wheelbase length, and this is the track width. So here you can see this angle is delta I and this angle is delta naught. Okay. Now let me draw a vertical from this point to this rear wheel lines, line joining the rear wheels. You get a triangle whose height is this wheelbase length, and this is R. Half of that I am deducting, so R minus T by 2. Then you will get delta I is equal to tan inverse of this. Similarly, I can draw a line here. I can find out delta naught. So for the given turning radius, what are the delta I or delta naught values? Or for the maximum di and delta I and delta naught, for the given wheelbase length and the track width, what is the maximum turning radius? You can find out from this. So this is what the trapezoidal geometry. This is the way the geometry will take the shape when it is taking a right turn, and when taking a left turn, this is the way it is going to assume the positions. Right. Now steering types. You can manually steer the vehicle, or you can use power assist. In manual steering system, using muscular energy, we steer the wheels of the vehicle. Here we use a power assist. Either it is a hydraulic power assist or electric power assist. So that's what I have written. Again, power assist can be hydraulic power or electric power. So this was the first one to be designed, invented and adopted. So whenever more effort is required to steer a vehicle, then hydraulic assist being used. Even now it is present in heavy vehicles. But however, in lighter vehicles, instead of hydraulic power, they use electric power, that is motor, EPAS, we call it as EPS, electric power assisted steering system. And of course, we use ECU so that we can easily steer the system, and moreover, this is very, very efficient system, compact and efficient. Correct, since it is a battery driven system. So nowadays, in a smaller vehicles, electric power assist is very, very popular, and still in heavy vehicles we use hydraulic power assist. Now here I have just explained the steering systems. One of the steering system I'm talking about is which is the most popular one is the rack and pinion steering system. So in a rack and pinion steering system, you can see this. This is what you can call it as steering wheel. Steering wheel. Then you have a steering column. And through the steering column, a steering shaft passes. This is the steering shaft. At the end of the steering shaft, here you can see to that a pinion is connected. So here we have a rack. So this is the rack. So as the pinion rotates, the rack will reciprocate. Either it will move left or right depending on the direction in which we steer the wheel. And to the end of this rack, you can see there is a tie rod. This is a tie rod. And this is connected to the steering arm. Right, steering arm here and here. And that will steer the system. So let us say you are steering in this direction. Steering in this direction. So that means pinion will rotate in this direction. Then your rack will move in this direction. It will move this way. And this will turn this. Like this. So if you do it in the other direction, means this way, so you'll get it. Like this. So that's how you can use rack and pinion steering system. And is the most simple one and very popular one. In some of the vehicles, you can find recirculating ball steering system. Sometimes it is known as pitman arm steering system. This arm is the pitman arm. Here we have the recirculating ball steering system, or you can call it as steering gearbox. Here it is written, gearbox, steering gearbox. So whatever effort we put in to multiply that, also the rotary motion of that, I should be able to convert into reciprocating, like to and fro motion. So now as we steer this, this might move like this, or depending on the direction, this way it will move. So that this will move up and down, so that it will be able to, depending on that, it will be able to pull this. This in turn will drive this tie rod in turn steering arm like this. So this is the another kind of steering system that we use. Okay, so how exactly this works, right? This one. So we use, I'll just explain this with a video. So as I mentioned that the steering components are, as I mentioned earlier, there is a steering wheel, then there is steering column, right? Then you have steering gearbox. This is what I call it as recirculating ball type. So rotate this, then this will move this way, right? Rotate this way. So that will be able to drive the pitman and other linkages. Sometimes they use worm and roller type kind of design too, right? And already I explained about the rack and pinion type gearbox. And this is the tie rod design. And how exactly it works, if you play this video, you will understand the working of this. Or you can look at the car also. Anyway, I am not recording this video. It's available on the YouTube. Correct? Type this keyword, get number of videos, and you can watch the video and understand the working of that. There are power assisted steering systems, as I mentioned earlier. So the question is, the road condition is very bad. The road offers too much of resistance. Then you require too much of effort for steering. It will put too much of stress on the driver. In such a situation, it is better we go for to enjoy driving, to make driving a real good experience, then it is better to use the power assisted one. So here you have the steering wheel, then the steering column. You can see here the pinion and the rack. Can we use some external power to make this rack move left or right? So what is that we can do here? Suppose I have here an oil reservoir, and suppose if I connect, then there is a pump. Let us say fluid pump you have, and the outlet of that, if I can connect it to this, you just see here. Now when I just steer it, if I can make connection between these two, then this pump is also driven by the, let us say, engine. Here you have the engine. It will be driven by the engine. It will take this fluid, pressurize this. The pressurized fluid, I'll just pass it on like this. Now this pressurized fluid, let us say, exert pressure on the piston. Okay, if it is exerting pressure on the piston like this, then this will pull the rack in this direction. Okay, if my intention is the other way, then I have to make the connection, right? This will go out, make the connection this way, so that make the fluid enter like this, then it will push the piston this way. So I can use this power, hydraulic power, and in addition to my driver's effort, we can provide this, the hydraulic power assisted this thing effort also, so that it is easy way we can move this rack, and that's how we can facilitate easy steering of the wheel. Correct? So this is what we call it as hydraulic power assisted steering system. Hydraulic power steering, they call it. So this is what I told you. You will have a reservoir, you will have a pump. So from the pump you can pump the pressurized fluid. However, you see here it is drive shaft. Where is this? Here. Correct. Now this is driven by the engine. The engine speed increases, the speed will also increase. So we should have special valves to reduce the steering fluid pressure as the engine speed increases. So that is what we call it as speed sensitive power steering. So here, pressure control valve. So we have to have a predetermined, we have to set the value and predetermined value at that pressure. It should take the fluid, pressurize it, and then send it to the valve. That's what exactly we need to do that, right? Okay. Fine, sir. Okay, now how exactly a hydraulic power steering works? I think you understood the theory. When you play the video, you can understand much better, and even you'll know how the pressure values that can be set. Another very important or nowadays very popular one is electric power assisted steering. They call it as EPAS system. You can see over here, you have the steering wheel, you have steering gears over here, and there we have a motor to drive this. Okay, that in turn, then there is pinion, then that will drive the rack. So we are using electric motor. So that's why it is called electric power assisted. Now let us look at this. You see your vehicle is running with particular speed. So vehicle speed sensor will give this value. That value is fed to the ECU. Whether you want to steer in this direction or this direction, the intention and the direction of steering angle and direction as well as the angle both will be known. So you will come to know which direction it should go. And also it will know what is the torque that you have applied, also what is the torque that is needed. So torque that you have applied and torque needed. So from that, so it will find out what exactly the amount of torque the motor has to develop. Accordingly, ECU will send the direction in which the motor should rotate. Also the torque to be developed by the motor to overcome this resistance. So accordingly it will manage the current value. So then the motor through reduction gear, of course this is also taken into consideration in the calculation. What is the torque amplification that happens? Accordingly it will make this rotate and this will drive these wheels. So this is how we are using EPAS system, electric power assisted steering system. So now the design of all these kind of things, like the loads, the forces that act on the wheel on a particular road surface, the torque required to drive this, then what is the torque amplification that happens, how the torque senses the torque, so what should be the torque that motor should develop. All these calculations we can do and design the system, and this kind of details we provide in another subject, what you can call it as the vehicle dynamics. There we teach about this. Here my intention is to make you familiar with the various types of steering systems. Okay, so electric power, the main thing is it is compact, efficient, and because of that I think the fuel consumption gets reduced. That means you can reduce automatically the emission levels. That way it is very, very useful. So again, there are many types, many designs in this also, in the EPAS system. Column assist type, you see here. Here I am using the motor. So here I am trying to rotate this column, then it will go to pinion. So whatever torque that it gets, it is driver's torque plus the torque developed by the motor, the giant, the total torque will be coming over here. So I can use column assist type. You see here another way is we can mount the motor here itself. It will assist the pinion to rotate, not in the column. Similarly, I can use a motor to drive this rack itself. So many different types of EPAS systems are available. Depending on the space available, the compactness, design, they place the motor at various positions. So if you play this video, you can find this on the YouTube, and you understand how exactly EPAS system in a BMW car works. Okay, another very interesting educational video is on YouTube, that is Learn Engineering. So you just ask the question how steering system works. This video will appear, you play this and understand how exactly a steering system works. So this gives us an idea about the steering system that we use in vehicles. So at this session we'll stop at this point, and in the next section we discuss about vehicle suspension system. Now thank you for patient hearing.